Hi there and welcome to Linear Algebra. Here in this video we want to deal with the scalar multiplication and addition of matrices. Now I do have two matrices here, matrix A and matrix B. What size are matrix A and matrix B? A is 2 by 3, B is 2 by 3. In other words, 2 rows and 3 columns. Now how do we add such matrices together? Now, we add corresponding elements. Let's write the big matrix here, which will be the result of A plus B. So, our first element is 3 plus 1. 3 must be added to the corresponding element in matrix B. So, it is going to be 3 plus 1. Our second element is 4 plus its corresponding element in B, which is 0. So it's 4 plus 0. Our third element in the first row is 9 plus 3. So it's 9 plus 3. Now we are done with the first row. Let's go to the second row. 0 is added to a 4. So we have 0 plus 4. Our 1 should be added to a 2. So it's 1 plus 2. Our 2 must be added to a 6. So we have 2 plus 6. Now let's simplify. This becomes equal to 3 plus 1 is 4. 4 plus 0 is 4. 9 plus 3 is 12. 0 plus 4 is 4. 1 plus 2 is 3. 2 plus 6 is 8. That is the sum of A and B. What about A minus B? Let us find the difference of A minus B. It's exactly the same principle, except that we are subtracting. We still have to subtract corresponding elements of each matrix. So here is our big matrix here, which will be the difference. So 3, we must subtract 1. So we have 3 minus 1. 4 minus 0. 4 minus 0 here. 9 minus 3. Minus 3. Down here, it's 0 minus 4. 1 minus 2. 2 minus 6. Simplifying, we get our matrix. 3 minus 1 is 2. 4 minus 0 is 4. 9 minus 3 is 6. 0 minus 4 is minus 4. 1 minus 2 is minus 1. 2 minus 6 is minus 4. That's the difference between A and B. Notice here, in both addition and subtraction, the result is always a matrix of the same size as A and B. Remember, in order for us to be able to conduct addition or subtraction of two matrices, they must be of the same size. And the result of that operation is a matrix still of the same size. Here, it's a 2 by 3 again, just like A and B. Now, we can also perform scalar multiplication. Scalar multiplication simply means multiplying the matrix by a number. Now, supposing we want 2A, the matrix 2A, the matrix A multiplied by 2, this will be equal to, and that is what is called scalar multiplication. It's equal to 2. Here is our matrix A, which is 3, 4, 9, 0, 1, 2. Now, we are going to multiply every element or entry by 2. And this gives us 2 times 3 is 6. 2 times 0 is 0. 2 times 4 is 8. 2 times 1 is 2. 2 times 9 is 18. 2 times 2 is 4. That's the result of multiplying A by scalar 2. Notice again, the resultant matrix still of the same size as A. Now we talked about, in the previous video, we discussed the double subscript notation, where we said a general element in A can be written as, in other words, an element in row I and column J in A can be represented as Aij, where Aij means it's an element in A in row I and column J. Similarly, an element in B in row I and column J would be Bij, row I, column J. So in terms of addition, we can represent this operation by A plus B. When we are adding matrix A to matrix B, it's a new matrix with elements of the form A, I, J plus B, I, J. In other words, every Ij is added to every Bj, just like we do. Our 3 here, which is in row 1 and column 1, should be added to B, column 1, row 1. Our 1 here, which is row 2, column 2, must be added to an element in B in row 2, column 2, which is the 2 there. So that's your addition in terms of the double subscript notation. Our next video is going to be dealing with multiplication of matrices. Slightly more complicated, but it's doable and it's easy to understand. Till then, bye.